Hello, my name is Tony Mora, and I'm going to be covering integration by parts today. I hope you learned something and enjoy the video. To begin, I'd like to talk about what integration by parts is and how it's derived. Integration by parts is essentially the process of making substitution for two different functions within an integral. The formula used for integration by parts actually derives from the product rule. When you get two functions and take the derivative of said functions, you get a prime non-prime plus non-prime prime function. If we then integrate on the right hand side and subtract one of the integrals to the left hand side and rearrange the whole problem, we get something similar to the original function that we used for integration by parts. To take things one step further and get it to the formula we're used to seeing, we need to do substitutions for both functions. In this case, since we're going to be using two substitutions, I'm going to use the variable u and the variable v. For u, I'm going to designate the f of x function, and for v, I'm going to designate the g of x functions. The derivative of both functions will be du for f prime and dv for g prime. After making all of our substitutions and inserting our new variables into the equation, we now have the formula that we need to do integration by parts, which is the integral u dv equals uv minus the integral v du. Now that we have the formula for integration by parts, let's go ahead and try an example. For this example, we're given the integral of x squared times sine x dx, and we're asked to evaluate. We can begin by designating a u and a dv for each function in this integral. In this case, x squared for u and dv equaling sine x dx. Since we still have two functions in the integral, it's required for us to take integration by parts again. This time we'll be using 2x for u and dv will be negative cosine x dx. After performing integration by parts twice, the answer to our integral is negative x squared times cosine x plus 2x times sine x plus 2 times cosine x plus a constant. Next, I'd like to talk about the tabular or DI method and how it's applicable to most IBPs. This method consists of a t-chart that separates the two functions by columns. On the left side, we have the f function, which has its derivative taken n amount of times. This column is usually designated u, or d for derivative. The g function has its antiderivative taken n amount of times and is usually labeled dv, or I for integral. The functions are then multiplied diagonally with alternating signs between each column. To demonstrate the tabular or DI method, we're going to use our previous example of integral of x squared times sine x. To begin, we're going to set up a table having the f and the g function on the left and on the right respectively. We're going to then take the derivative and antiderivative of those functions, which produces negative 2x and negative cosine x. Then the derivative and antiderivative again, which produces 2 and negative sine x. And finally 0 and cosine x, which when arranged gives you the previous answer that we got in our last example. Next, I'd like to touch upon cyclical IBP. A cyclical case is when the original integral shows up in the equation after doing integration by parts. To demonstrate a cyclical IBP, we're going to evaluate the integral of e to the x times sine x. Once we make our substitutions and do IBP, we get the equation shown here. But after our first application of IBP, we still have two functions in the integral, so we must do another application of IBP. But before we do that, we're going to push out a constant from the integral. In this case, we take out the negative 1, which gives us a positive integral e to the x times cosine x. Next, we integrate and do IBP one more time. And now we see that we actually have the integral that we started with in our integration by parts. From here, we just need to add the integral to both sides, doubling the original integral that we started with. From here, we're just one step away from our answer. So we need to isolate the original integral by dividing both sides by 2, which gives us negative e to the x times cosine x plus e to the x times sine x over 2 and a constant. I have provided 3 quiz questions for you, the viewer, to pause the video and try to answer on your own. Question 1 is, what would be the v sub if dv equals x to the negative 1 dx for the integral below? Natural log of x, x to the negative 2, or 1? The answer was ln x, natural log of x. Question number 2. The tabular/DI method uses what notation? Please remember to pause the video to try to answer these on your own. The possible answers for this question are u and v, or d and I, u and dv, or d and I, du and dv, or d and I. The correct answer was u and dv, or d and I. Now for my last question. For question number 3, I would like you to evaluate the integral of e to the x times cosine x dx. If you paused the video and took a crack at the question, you should have one of the 3 possible answers that I listed below. In a couple seconds, I'll let you know which one it is. And the answer was the middle one, e to the x times cosine x plus e to the x times sine x over 2 and a constant. So now I'd like to thank you for sticking it out to the end of the video. I hope this was informative or a refresher for some, and I hope you have a wonderful remainder of your day. Thank you.